In suburban Charlotte, North Carolina, Duke Energy is powering up the future of delivering electricity. It's testing a smart grid that can reduce the need for future power plants, save consumers money, and even heal itself when the lights go out, thanks to wireless. At the heart of the smart grid are wireless communication nodes, which serve as a hub for data flow and communications.
It's got a multifunction antenna that also has a GPS built into it. It has a computer and processor on board. Inside here you can actually see the cellular card that allows us to do multifunction or multi-carrier cellular for the message traffic on this device.
One of the main sources of data to the nodes are line sensors, which measure current flow and other information on grid performance.
They feed that information back to the communications node, which then via cellular sends that information back to us. We're then able to make decisions about how that power actually routes through the system.
If power is lost on a traditional grid, an entire neighborhood may go dark, but a smart grid can self-correct. Line sensors tell the wireless communication nodes where power is out. The nodes then activate switches to reroute power in the affected area within seconds. They also transmit the outage location to Duke so that crews can be dispatched for quicker repair. Another major challenge for utilities is meeting peak demand.
The biggest problem we have is since we have to build to the peak, it means building more power plants, building more infrastructure, and overbuilding essentially what we would have to do to supply the customer.
The smart grid tackles the peak demand problem by adding local power sources, including solar panels and batteries at the substation. Batteries are also located at the transformers, along with wireless communication nodes, which provide local intelligence between the grid and the house. During hot summer days when demand pushes capacity, power line sensors tell the wireless communication nodes that there's strain on the system. The nodes then tell smart appliances in participating homes to adjust their energy use. Solar power and battery backups are also signaled to feed into the grid. All systems are activated within seconds, working together to shave peak demand. When demand drops, the grid goes back to normal. The Duke system also gives homeowners the choice to control their energy use and smart appliances using a wireless device, while smart meters allow near real-time tracking of energy consumption. Charlotte residents have glimpsed the future, a smart grid that combines new energy capabilities with intelligence through wireless. It's helping save electricity, money, and the planet.
From power plant to transmission to distribution to customer, we can now manage it together to really achieve these objectives on carbon, greenhouse gas emissions, really on a cleaner and better environment.